Okay, folks. So in the last unit, we were learning about orbital notation, electron configurations, and we very briefly learned how to do electron dot formulas. And electron dot formulas are simply putting the number of dots around the element symbol that match the number of electrons in the highest energy level. Now, this is a black and white copy, but originally yesterday, these two electrons here were red, showing that we put extra electrons in there. The actual orbital notation for oxygen only had 4 electrons in the p sublevel. The second, I put an extra one in there. Should have stopped. Okay? And so to get to what oxygen wants to have, you got to fill up the remaining orbitals in that highest energy level. And the highest energy level is the second primary level. 2 is the highest energy level. Okay? And there are 2 orbitals in the highest energy level for oxygen. So to get oxygen to be as stable as it can be, we're going to try to make it have the same orbital notation as a noble gas. And the nearest noble gas to oxygen is neon. Neon has a full set of orbitals, and that's what we're trying to do, stabilize everything as much as we can. And that's what this system here, this is all part of the Vesper theory, valence shell, electron pair repulsion. Okay, valence shell electron pair repulsion. V-S-E-P-R, valence shell electron pair repulsion, Vesper. Usually it's pronounced Vesper, but it's probably Vesper. Okay, so by sharing electrons with a hydrogen, remember this hydrogen really only has one of these 2 electrons. Again, this is black and white. The original hydrogen atom only had 1 electron in the 1s sublevel. Okay, and so what we're showing is that you can share the electrons in the orbitals. The actual orbitals are being shared. So when covalent bonding occurs, you're not just sharing electrons, you are sharing orbitals. So in physical science, you were taught that covalent bonding was sharing electrons. And we're going to take that a step further now. Okay? When covalent bonding occurs, you not only share electrons, you also share orbitals. Okay? And then shared orbitals are what are called the bonds. Okay? Shared orbitals are called bonds. Covalent bonds. And there are 2 types of covalent bonds. Sigma, that's the Greek letter, small letter s, sigma. So sigma became the S in the English language. The capital letter sigma looks like a capital E turned backwards, or no. It kind of looks like a capital E. It's kind of strange looking. And pi, and you already know what pi looks like, I hope. Okay? So that's the Greek letter for our P. And s orbitals, the way we get these is the sigma bond sort of derives out of the s orbital. Pi bonds derive out of the p orbitals. Okay? Now you can get sigma bonds from p orbitals that hybridize. We'll get to all that, but that's kind of where you get the beginnings of the storyline. All right, now, so what we're doing, what I asked you to do last night was simply to take this sharing using using electron dot formulas to start with, and showing the sharing arrangement, finally coming up with a Lewis dot formula, and predict. This is for water. This is the example I gave you. To do the same thing for sulfur dichloride. Okay. So to do that, we have to start the same way we did up here. If you followed all the steps, you should be able to get it. So here's sulfur. I'm going to do its orbital notation first. So a lot of you had some struggles with the orbital notation on the test. You need to go back and review because we're still using orbital notation. If you can't do it on the first test and we're getting the second test, then you need to come in and get help. I'll help you, but you know what? If you choose to flounder, you know, you're choosing to drown. It's up to you. I'll help you, but you've got to help yourself too.
What does it mean to flounder?
Not being able to swim very well, so slapping around in the water, that kind of thing. Huh? We're not talking about the fish.
Oh.
We're talking about flounder being something that you do, not the fish of flounder.
Oh, so it's a verb and a noun.
You thought it was
Well, let's see. Flound is not. Let's see.
So flounder, that's a verb.
Yeah, it can be used as a verb. I'm using it as the subject, object of a sentence. What? What?
Is a flounder?
If you want you to take it out of the water, sure. I don't know why they call a flounder a flounder. I have no idea. Okay? Maybe they got the verb or adverb or noun from the fish or the fish or the noun. I don't know. I don't know which one came first. Was it the chicken or the egg? I don't know. All right, let's go back to chemistry. So all of the second primary level is full in sulfur. We get to its valence level, we're in the third primary level. So we're in the third row, 1, 2, 3, and that's where we encounter sulfur here. Okay, so we're going to fill up. This is the third row, so that's the third. That's in our orbital notation. That's the primary level 3. This is the sublevel S over here. These first two columns make up the S sublevel. If we move the helium over here, and then when we get over here, we're in the P sublevel. So we're going to fill up 3s with 2 electrons that are corresponding to sodium and magnesium. Then we're going over here, and we have 4 electrons, 1, 2, 3, 4, when we get to sulfur, and this region of the periodic table is the P sublevel region. Some of you got that wrong on the test too. And so we need 4 more electrons, 1, 2, 3, 4. And so that looks a lot like oxygen's orbital notation. If you'll take a look at oxygen, it has 1, 2, 3, 4, 5, 6 electrons in the highest energy level. That's its valence level. So we have the same number of electrons in the valence level of sulfur. So because sulfur has the same electron structure in that highest energy level, and the highest energy level is the one that does the bonding, sulfur should bond in the same way that oxygen does. At least that's a reasonable model or prediction. Or hypothesis, maybe, if I make it a prediction. Okay? So then we're going to put it together with, we say chlorine. So here's chlorine. And chlorine is right next to sulfur. So that's sulfur's electron configuration, and chlorine just has 1 more electron. So we've gone all through how to do this. Okay, we talked about what all these boxes mean. Those are the orbitals, what the sublevels mean. We talked about electron structure and how it actually relates to the physical structure of the atom. We drew concentric circles to show how these electrons are all arranging themselves. Okay? But the structure of the electron cloud becomes more complex than we can do with those concentric circles. And so we're getting into some theory where you have to kind of imagine what's going on, because it's impossible to draw it without it becoming so complex it's hard to make sense of it anymore. So your brain is a more effective tool at understanding what's going on than drawings on a piece of paper. And so I expect you to use that tool. Okay? God gave it to you for something, right? Yeah? Yeah? Use your brain. Okay. So now let's do the electron dot formula here for sulfur. So how many electron dots do I put around the sulfur symbol? Well, let's count. This is the highest energy level, 3. The third level is the highest energy level. So all these electrons are part of the valence level or highest energy level of sulfur. So how many dots do I need?
I was putting all of them in there. I had like,
Everything from down to here?
yeah, I had like,
Oh, gee.
6.
6 of them.
Right now, like 30 dollars.
1, 2, 3, 4. Okay. We're going to put 1 on each of the 4 imaginary sides of a square.
yeah, 13
And then
dots
when
on
you
each
have the
side.
share,
And then we go back and we pair up
Yeah.
2 more to get to 6. What now?
I have 13 dots on each side.
Well, I'm sorry. So I can put them on any of the 4 sides I want to. It doesn't matter. I'm going to choose to put them like that, okay? Nothing special about pairing them up on the top and left. I could pair them up on the bottom and the right, or the left and the right. Doesn't matter, okay? So can you do the electron dot formula for chlorine now? Oh, I didn't tell you all to exchange papers, did I?
no.
Yeah, let's exchange your papers.
What?
Exchange your papers with somebody else, unless you want me to grade it. If you want me to grade it, give it to me.
I was doing all this for notes.
Well, you're supposed to have your homework. If you have your homework, you need to exchange your homework paper with somebody else. So I've gotten you up to this point already, so I'm kind of giving you some points here. Has everybody exchanged their homework paper?
No.
What are we waiting on here? Well, I'm not going to wait on it. I'm going to get out of 0 if you don't step up here. Come on.
Not all there today.
All right, has everybody exchanged their homework paper with someone who also has their homework? Don't exchange with somebody who doesn't have their homework. If they don't have their homework, they should be taking notes. Okay? Don't exchange with somebody who does not have their homework. Exchange with somebody who has their homework. Got that? Okay. So that's sulfur. So how many electron dots do I need around chlorine then?
Yeah,
7. 1, 2, 3, 4. There's our 4 around the central atom. And then we're going to put 3 more on there, and we're going to pair them up anywhere you want to. How about I do it like that? Doesn't matter which of the 3 sides you pair it up on. Okay? Now, what we're trying to get is to get sulfur to have a full valence level. How many electrons do I need to have a full valence level? 2 more, for a total of 8. How many do I need in chlorine? 1 more. So what I want to do then is to go and share electrons between sulfur and chlorine here. And that gives chlorine the 1 electron it needs right here. Okay? So chlorine is going to be full. But this sulfur, I still need 1 more electron. So to make that work out, then I need another chlorine atom. Okay? Because the chlorine needs 1 more electron. The sulfur now, I've got 1 electron here. I haven't drawn it in, but it's there. And we need one more electron. I could pencil in, I suppose, if I had something with a slight different shade. How about I use this? So I've already put in an electron here. I put in an electron here. And now if I share between these two electrons, I didn't draw out another orbital notation for chlorine, but I could and show that by sharing I'm putting an extra electron in there. Does everybody understand that's what I'm doing, even though I'm not drawing it? Okay, I see some people are shaking their head, and I see one person who's like about to go to sleep with his hand on his head, with his head on his fist. Okay. Are you okay, Patrick? No? You sick? You need to go to the nurse? No? Okay. All right, we just want to make sure you're okay. All right, so that then gives the sulfur all the electrons it wants to have a full valence level, because we just put that extra electron in here. Okay? And it gave both these chlorines the electrons they need. Okay? So now we started with the electron dot formula. When we just put the dots around the atoms, that's the electron dot formula. But now that we've shown how they share electrons, now we have a sharing arrangement. And the last step is simply to squeeze the shared electrons between the two atoms. Okay? So you kind of think of these as little squishy rubber balls. When you push them together, they eventually kind of slide beside each other. Okay? So if I have this sulfur here, and I'm going to squeeze these two electrons in between the two atoms, eventually they're going to kind of squirt side to side. Does that make sense? Okay? And these are going to do the same thing, side to side like this. Okay? Now, I've explained all this to you, okay? If you start putting in electrons up and down between these two, that's going to be wrong. I've explained to you how they go, okay? All right? You know, they've got to be side to side when they're on the top and bottom, and over and under when they're side to side. Okay? When they're on the sides, side to side, they go over and under. When on the top and bottom, they go side to side. Two kinds of shotguns. Double barrel and over and under. Double barrel goes on the top and bottom. Over and under goes on the sides. You don't get it? That's what I'm saying. There's double barrel right there. Think about looking down the wrong end of a double barrel shotgun. No, it's not. But the double barrel goes top and bottom. Over and under shotguns go side to side. And that might not... Shh. Now, since we're in South Carolina, and a lot of guys in here go hunting, you know what I'm talking about. Some of the girls might not have a clue. Some of the guys might not have a clue. That's okay. What? I don't mean to be sexist or anything, but we all know that guys tend to go hunting more than girls do. Really? Oh, well, there you go. Okay. But nevertheless, even though you may be one of those, South Carolina girls that go hunting or go shooting, great, that's fantastic. But really, in numbers, if we're going to look at numbers, you know. Well, that's true. In fact, all right, so that is what do you call this kind of drawing then? What's this drawing called? Nope. Lewis dot formula. Well, I don't know if you don't tell me. Yes, ma'am.
A student of yours, I don't think she'll say her name, wants to know why do you do it like that?
What?
Why do you have to do it like that? That Lewis dot formula. She want to know why that is.
Why do you have to draw a Lewis dot formula, or why do you put the over and under side to side?
Yeah, why do you connect it like that instead of doing it like that? How you circle the top, you connect it at the bottom. She want to know how you do it. Why do you do it?
Because is it?
Okay, sorry,
Oh, because the convention is to put them double barrel on top and bottom, over and under side to side.
Did you want them all? It's not
Yeah, you're kind of condensing the space, I bet. Okay. When you get to more complex drawings, starting off with this makes a lot of sense. But till we get to the more complex stuff, it's we're kind of building up right now. We're just laying the foundation right now. Okay. All right then. Let's come up with a grading scheme for this. All right. So I gave you orbital notation for the sulfur a while ago. I'm not going to give you points for that. Okay. I'm going to give you 1 point for having the orbital notation of chlorine correct. I'm sorry, the electron dot formula for chlorine correct. Okay? 1 point. I'm going to give you another point for this chlorine being correct. I'm going to give you a point for sharing electrons. Oops, should be 1. Okay. And 1 point here for sharing electrons correctly. Okay? Yes.
Can you come here for a second?
Yeah, let me finish going through this and then I'll come over there, all right?
I know, I got 0 points.
Okay. Now, since what you have to do is squeeze the electrons in between here, the squeezed electrons are going to be worth 1 point.
I didn't even know you had to do that.
The squeezed electrons are here are worth 1 point. Okay? And the remaining electrons being all the way around like this, I want to make the remaining, the fact, if they put it side to side here instead of over under, we won't count it wrong this time. But I want you to write a really nasty note on there saying, don't you ever do this again or you will be shot with a double barrel shotgun. No, don't say that. Don't say that. Don't say that. Okay. All right? Yeah, if you do it like this again, choose the right shotgun, either over or under or side by side. Okay? All right. No, don't do that. I'm just kidding, okay? Just trying to emphasize the idea that top and bottom, double barrel, side to side, over and under. Got it?
So right now you're not going to count their Valence dot formula as long as they get the shared around.
As long as they get it shared properly and they have all these dots here, because I'm going to give you also a 1 point for putting all the remaining dots and symbols on there. Okay? Got it?
You can show us that yesterday, because I don't remember that.
It's right here.
Oh.
Yes, this was the notes. I copied this off the notes that I scanned during second period
I have a
yesterday.
question, Mr. Pettit.
Yeah.
Since we didn't learn the dot stuff until yesterday, and it was on our test, is it covered at all still? Because it was on our test.
Yeah, but only not sharing was on the test, was it?
Yeah. I like the short answer.
Did we not do this one?
No. You had to draw an electron dot formula. You were shown that. Electron dot formulas you were shown, but not sharing of electrons.
I don't remember doing the dot stuff.
Really?
Yeah.
I'll consider revisiting it. Okay, I'll go back and look at it again. All right. But you know what? It was in the practice test.
Was it?
Yeah. So I gave you the opportunity to go look it up or ask me about it. That's what that practice test is for. To make sure you get it. Huh? You know, if you were out or you did miss it or you were, talking to somebody and weren't paying attention, then that's a chance for you to catch up. You can always ask questions. Answers sometimes cost money. What? What? Yeah, give me 1 second, okay? All right, so we're talking about 1, 2, 3, 4, 5, 6, 7 points on this quiz, okay?